Yeah, or you can take your phone.
Oh, I don't want to
Oh, that is.
Absolutely play.
One percent of my salary every month. I don't get $1,200.
Gotta play.
But
Makes you care.
Doing branch checkouts. So I figured how to see all the branches in a repo.
All right, everyone, let's go ahead and start. I think a lot of people are cashing in the like 4 days off or 4 like missed lectures, but that's fine. We'll go ahead and start, and then hopefully, y'all can tell your friends that maybe aren't here, because I think we're going to be going over some stuff for the final skill demo before Thursday. So I think maybe you can spread the word. So that's like watch the recording. I'll also send out an announcement on this then. Oh, yeah, week 10 makes sense. Makes sense. But let's go ahead and start with one of the geography games. Actually, we sort of were rushed last week. So if y'all don't remember this game, we just type out some like country and then it'll tell us if we're hot or cold, basically. So who wants to just like throw out a country name to start?
India. Brazil.
Brazil. All right, let's do Brazil.
Thank you.
Okay, so that's okay. We're 6,000 miles away, but we could get closer. Anyone give another one?
India.
India. Oh, okay, 2,300 miles. Other guesses? I think we're going in the right. Oh wait, maybe it's not in the right. Maybe it's somewhere in Africa.
Italy.
Italy. Cooler. Okay. So the order is India was the closest, then Italy, then Brazil.
Singapore.
Let's see. Oh, warmer. Wow. So small. Okay. Okay, wait, but India's still the closest. Let's guess a few more. And y'all can plug Google Maps too if you need it. That's fine. Yeah.
Kenya.
Canada?
Kenya.
Kenya. Okay. Okay, whoa. Like, we're guessing. Alright, let's guess a few more. I wonder if there's like an upper bound of wrong answers.
How far is Kenya? How
far is Kenya? 1,600.
Morocco.
Cooler. Okay, this is tough. Let's just start yelling out names.
Saudi Arabia.
Okay, yeah, I think maybe the Middle East. Warmer. Okay. What's still 1,000? Kenya was still the closest though, so maybe not Middle East. Rwanda. Warmer. You just walked in, you thought you could write it. Okay, let's just, alright, some other African countries. I'm guessing take East Africa and North Africa maybe. Nigeria is west. Let's do Ethiopia. Warmer. Somalia. Warmer. Tanzania. Warmer. What?
South Africa.
I don't know. Maybe. Cooler. Okay, it's gotta be like whatever is like right here. Basically.
It's closer south.
Yeah. I can't move my thing. Okay, here. It'll be somewhere here, right? Or you think here?
No, it's even further south. It's next to like Mozambique right there. Yeah.
Okay, what should we get?
Zimbabwe.
Zimbabwe. Oh my god, this is crazy. It's gotta be like.
Madagascar?
Ooh, nice. Oh, okay, but that's super close. That's super close. Okay, what country's right here? Mozambique. What? What's right here? Wow. Is this a country or is this part of something?
Seychelles.
Yeah, this is what I meant. Oh my god. I don't know, you just give up? I'm not really sure.
It's like reunion, Mauritius.
Can I just see the answer?
Yeah.
Mauritius?
Yeah, Mauritius.
Yes, okay, nice. Oh my god, that took so long. Okay, alright, let's go ahead and start with announcements, and now, that was good, because a lot more people have joined since 3:30. So, alright, one major announcement, we have the final skill demo on Thursday. I'll be going over like a short demo of the practice skill demo that we had a couple weeks ago today to just show you an example of what will be going on. Remember, actually this is related to announcement 3 as well, but you should be doing exploration activity 3, where you're just going to be creating a few matplotlib plots, okay? Like, you know, the final skill demo will be on the matplotlib code base, but there's no point in sort of starting to learn it right now. It's really large, it's like maybe like 5 times larger than the idlib code base. So just be familiar with what matplotlib is, and then that's sort of like all you need for the final skill demo. We're going to be trying something out where we're going to have y'all screen record just the like Google Chrome window of the skill demo. This will be a way for us to give partial credit, and it's also really related to like the research that Gerald and I do, so we'll be able to sort of see what some effective and ineffective techniques are that our students are using. It'll all be de-anonymized when we're analyzing it. But if you do have any concerns about this, you can like email me or post privately on EdSTEM. Let us know if you do have some concerns with this. Like one thing that I think the main concern would probably just be battery on your laptop. So I'll just say like bring your laptop fully charged on Thursday and maybe even bring a charger. But you know, worst comes to worst, we can just stop the screen recording and you can just continue to do the skill demo. But yeah, this is something that we're going to try out as well. So please let me know on a private post on EdSTEM or something if you do have any concerns with that, okay? And then next, the final presentation detail. So actually this is a slight update. So if y'all had already started preparing your presentation, we initially had it scheduled for like a maximum of 15 minutes. But for the final presentation, we actually reserved this room and the room like right next to us. So we'll be able to have like 2 rooms in parallel. And so we'll like split up the 12 teams in like 6 teams and 6 teams. So we have way more time per group. You don't have to use the extra time. So we're saying the upper bound now is 25 minutes. Okay, you can have your presentation be up to 25 minutes, but I don't know if you need all that time. Remember, we want to keep these engaging and useful and informative. So you don't just have to like talk for the sake of talking. Now you just have like more time to work. Okay. And one more thing, actually, I'm just gonna write it right now. Like I'm just gonna say, make this engaging and interactive. Okay. So we actually have a little bit of an update on this like link where we have the instructions for the final project. I think we're like highly encouraging. I guess you don't technically have to. We won't like enforce it, but do some sort of like activity or some sort of interactive component or something that keeps the presentation a bit more engaging. Okay, like you can think of like what we've done in some of these lectures where we like ask you to complete a small part of a task on your own, or you can have a little Google form or a little short quiz or something where the audience is like answering questions. But since we're going to be sitting here for a couple hours for everyone, let's try to like keep these engaging, and keeping our audience engaged is also a big part of like getting our message across, right? So yeah, that's just going to be something that we're going to look out for in the final presentation. Are there any questions on any of these announcements? Yeah.
You said that the final presentation will be parallel, so would we still be here for the whole time?
You'll be here for the whole time, but rather, I think it'll probably be 2 hours in each room. So like, I think me and one tutor will be in this room, and then the 2 other tutors will be in that room, and we'll sort of have just our own rubric and grade it like that. You'll still stay for the whole time, you'll watch all the other presentations, but it'll be like, we'll probably only use 2 hours of the 3 hours instead. We'll also do a break probably after 3 of the presentations and just let people walk around or use the restroom or something. Any other questions on these announcements? Okay, cool. So today's agenda, we're going to start with the code walkthrough presentations. We have 2 more to get through. So I think we're on these last 2 here. So this team with Zichen, Steven, Yang, and Bang Zhao for y'all. Okay. And then also remember who is asking questions, okay? I won't be like checking that, but just make sure your team is on top of that. Okay, whatever.
And then I figured out the which. Yeah, because like that way it works.
Then let's make the font bigger as well on all the VS Code and stuff.
That good, Kevin? Alright, so our feature flow. Yeah, alright. Our feature is check module. So let me open up the file. So I put a syntax here, obviously. And then this is what happens when you click the check module. Alright. Oh. It's not working like I wanted to. Oh. One second. You'll see what that was about. All right, so we have syntax here, and then we click check module, and it's going to tell us there's an invalid syntax, right? And then when I click OK, it's going to bring me back to where the syntax here is in highlight. All right, so then to do a code walkthrough, we define the code first, right? So then we will do Google search, check module, and then we go into the README file, which is right here, and then we see that in the run script file, we have this function, right? So then I will look for that, and then this function name, and then it links us here. This is a small function, or it looks like a small function, but all the helpers are really long, so we decided to keep it short and then only work on show you the check syntax function. Here. Yeah, and then Steven here will show you guys the UML diagram.
So this is our UML diagram. So the class name is called script binding, and it has two important attributes. One of them is the attribute, and the other one is netlist, which is the file list. So we need these two to gain access to the editor and also the files. And then the other ones are the root, click bars, and graph. And then within the check syntax function, we have another function called the error box. So that is to display the errors to the users. And then on the right, we have the other functions that are outside the script binding classes that are called by the check syntax function. And then on the top, we have the get warning string and the set warning string functions inside the PyShell class. We have the open shell function inside the PyShell file list class. And then we also have the colorized syntax error function inside the editor window. So that's to highlight the errors. And then we also have the tag remove function inside the text class. And that is to remove any previous errors in the files to avoid confusion with the errors. So we go back to the code. So at first, we obviously have to open the shell. And then these two lines of code here is to basically redirect any warnings, so like deprecation warnings generated during the syntax check. And then we have to redirect those warnings to the standard error outputs. And then so that these warnings can be displayed to the users. And next we will have Yangang to explain how we can mobilize the files before we compile them.
Okay, I'll use debugger to demonstrate how this part code to do the normalization, especially this part. So you can normalize all things, like for use back session for new life factor. I first I'm gonna set breakpoints at line 87, so then we can see what is the content inside the variable source. I just open an existing file. From here, then I just check the module. Okay, as we can see here, that's the binary code. Yeah, that's the binary code it starts in the variable source. As we can see, we use back session for the new life vector. We step over against step all the normalized step. So then it's here we basically gonna check the source. This the source variable is empty or not, and you're gonna check and if ending with back session is escape, or otherwise you're gonna kind of back session. So I will show another example like for different machines, especially for Windows. So as we can see, so if you're using Windows, so the binary code again looks like this. This is from ChatGPT. So we're gonna use backslash or backslash for the left vector. So I do the same thing, set breakpoints here. So I run the debugger. Oh, yeah. Yeah, so I use the slides force the source to be this one. That's the binary code format. So right now it doesn't matter what file I open, the binary code is gonna be the same from the ChatGPT. This is Python check module. Right now, before you do the normalization, as we can see, that's the binary code for Windows. It uses backslash or backslash for the new life vector. So you're gonna do the normalize after, basically after this two step. So when I do step over, it first gonna move here. So you're gonna do the normalize step. So step over. So then after you do the normalize, we can see right now they use backslash for the new life vectors. So the rest are the same. That's all I'm
Alright, moving along to the last part where we try to compile the file and we get the editor from the constructor and the actual text. We remove any previous existing tags from previous syntax 0 to make sure current a fresh start for and then we try to compile where we're passing the source code, file name, and indicate the mode of the compile. And we can command click to see what this compile function looks like. It's in a built-in file in Python, and it takes these parameters. And we accept 3 types of errors, syntax error, overflow, and value. And we're going to explain more about the syntax error, where there's 3 attributes we're going to use later on. Message, line number, and offset, which is the column location for indicating the specific location of the syntax error. We command minus back. We can see that we get these information using the get attributes. If there's nothing, if the arrow does not have those attributes like overflow, you can see there's nothing, no attribute for this arrow, and for value arrow, which is also have nothing. We will give them a default empty value and set that to some default value, 1 or 0 or something. And later on, we're gonna see what those values look like in the actual file. in here, if the offset is 0, which indicate that the syntax error happened between two lines, so we increment the line number to tell the user, hey, something's going on between those lines. So a user can take a look. And we create a pose passing line number decrement by 1 because this is a parameter used for colorized syntax error, which is using 0 index, whereas in user we're using 1's index. Line number 0 doesn't make any sense to the user. And let's show the open the file. So you can see there's a syntax error here. When we do the check module, give the error box, which just said invalid syntax error. And we can use the print line here to see, okay, the line number is 1, the offset is 7, which is from here's 1, 2, 3, 4. Here's the 7, and then the message is the invalid syntax error. And in here, lastly, we use pop a error box to tell the user. One of the improvements we think we can make is to, in the error box, we tell the user, hey, the specific syntax error happened at this line and this columns. So if we did that change, we open the same file and check the syntax. In the error box, will indicate the location of the syntax error. We think that's helpful, and return false to ending this. Lastly, we unmute the warning. So keep the warning back on for later compiler Python mode. And that's all on the presentation. Is there any questions?
So we do include the backslash r argument. So what's the backslash r?
Oh, those part basically for different machine you're gonna use different
New line.
new line character.
Oh,
So for especially here for Windows and Linux they use backslash or backslash n. For all Mac they use backslash r. So it has to normalize it to backslash n.
Yeah, in order to make the call work for different machines, they have to normalize this before compile.
yeah, that makes sense.
I guess for the exact statement, why is it only cached 3 pairs? You just one, did it cache for if it's an array, I guess I also cache F2 or check mark.
Yeah, actually, we also discussed this. It actually does not catch any of the overflow and value error. Here, it actually only catches the syntax error.
Okay, you know why, or is that?
I would say it's a runtime error, right? So this is checking the syntax error.
Okay, alright, let's wrap this one up. Okay, then we have our last group.
The final was 11:30 to 2:30, so he just we were just eating downstairs outside service.
All right, everyone, let's go ahead and give our attention to the last code walkthrough presentation.
Okay, well, hi everyone. How was week 10 going? Yeah. Okay, well, I'm Alma,
I'm Sophia.
I'm Alan.
and we're gonna talk about a feature that has a lot of potential. We'll phrase it like that. It's called the show completions feature, and so if you ever happen to go to edit and scroll down, you'll go to line, we can see the show completions feature. And this feature kind of works like autocomplete. So if we click it, it will show, can you see this? Okay, I'm assuming that's it. So it shows in alphabetical order, or more likely by the ASCII value, or like the options that it has access to within the scope. It shows different commands or methods that we can talk to. And for example, if we start typing print, then or P, then you can see that it jumps to P. So the thing is with this feature, it doesn't eliminate the other options that don't start with P. It just goes to the location where in the list where words that start with P, and then if we continue doing that, then it will jump to that as well. And if we want the option that we if we want print, for example, if we want to write print, and we wanted to show at the top, then we would have to do control space, which is another way to invoke this feature, and then print goes to the top. So yay, but so it can be useful. Oh my god, what are they doing upstairs?
Having a ride.
That's ridiculous.
Yeah, you can use the up and down arrows. Oh my god. To go. Okay, you can use the up and down arrow to go up and down. And again, it's kind of weird because even though we started from writing PR, we're now an object, so yeah, exactly. Okay, another thing that the show completions feature can do is if you want to import libraries or use libraries, then you can do, for example, import datetime, and then when you do control space to invoke this feature, and you start writing datetime, then it's added to the list of options that are within the scope. But if you want to access something within the library, then you can press enter to pick datetime and then dot, and then either you do control space to invoke it, or after a few seconds, it will show the list of commands or variables that are defined in the library. So I forgot to show that datetime wasn't there before we imported datetime, so I'll just show for example, if we wanted to import the math library or use the math library, and we did control space, and we navigated to MA, so you can see that math doesn't show up here, but after we do import math, control space, yeah, so it's right there. Another thing that's weird is if we wanted to, for example, if sorry, I'm really sorry. Okay, great. Okay, just checking that I can. So, if we wanted, for example, to use daytime, but daytime doesn't exist, then, like, even though we're clearly not writing daytime, if we did, like, for example, tab is another way to look at it. So, an interesting thing is if you start writing something that or if you wrote something that IDLE recognizes, like print, for example, and you do tab, then it will do normal tab. But if you do something that IDLE, so for example, PR, it will recognize, so it will show the list of, or it will not recognize, so it will show the list of options that are possible. Same thing with daytime. So even though we have, for example, daytime is a thing, but it doesn't recognize it yet. So I did escape to to get out of the menu. So if I did control space again, it will show it because it doesn't recognize it. And then if I did tab, then it will just switch it to the first option that it deems like the closest to what we wrote. But yeah, I don't know how useful that is, but it does that. And then the last thing is if we have, for example, like a class, I just wrote this today. And let's say that we define a person, Anshul, person, and so his name is Anshul, and his hobby is playing GR. Okay. And then I did something like and then I did front. Okay. So Angela enjoys playing video games. And now let's suppose if I did, for example, control space, and I started typing AN, you can see Anshul here. So yeah, so now it's a variable. If we do Anshul name, Anshul. So that's fun. And so after you save and run the model, this will also work here. So for example, if we wanted to print Anshul dot describe again, this time it will show me Anshul as an option. Or actually, let's do this tab, so it will complete it. And then if I wait, there we go. Describe model. Okay. Yeah. And then just one last thing. If we create another person, like me, and you do person, and you open the parentheses, then it will show the class variables that we defined earlier. But you first need to save and run Anshul for this to happen. So I don't know if you noticed, but before when I created Anshul, this didn't do that yet because I didn't run the model. Yeah. Okay. And then so like we said, there you can invoke it using like the period. So if you do something like math dot, I should remember math. If you do math dot something and you wait, then it shows different options. And then also, if you start with parentheses, then it will show, you can see that it shows a different collection of options. So these are files. And if you do slash and you do curl space again, then it will show directories on or on Alan's laptop. Yeah. Hopefully that wasn't confusing. So, yeah, lots of potential.
All right, so we kind of already talked about what it does, but how it does it. So this is kind of leading to the UML diagram. So we of course start with main menu, like with many other options that we have encountered with this class. And after that, it is activated in editor.py, and we're going to call it to this file called auto.py. So what it does is we have a few functions that are very important. The first one, of course, is initialization. The second one is called an autocomplete event. That is what kind of starts this whole thing up. But after, there's two cool features that can be done. There's one called open completions and one called try open completions event. And so remember that delay when you press period or you press the slash? The try open completions event, that is used to open it after delay, versus open completion will do it when you invoke it using tab or Control S. Also, there is an important thing that handles key bindings, which would be, that is controlled by force open completions event. And then after, one of the more important features is fetching completions. And so it will fetch the relevant completions in the editor. And how it does it, there's two ways. If we have a Python subprocess running, it will use that to generate the completion list. If not, then there's going to be, it's going to be generating a list from the current process. And you might ask, what is that? So when we invoke open completions, we have two more things that pop up. So we have the hyper parser, which will parse. And then we also have another file called autocomplete window. And so that is really what is controlling finding the correct options. So for example, we'll have like binary search, and that will perform the binary search on the completions list to find the index of start. So into autocomplete window, we pass in certain parameters, such as the list of completions, the mode, which, and for example, the mode is whether we're looking for files or we're just looking for attributes in a certain class, and of course, start, index, and start, which tell us how many letters have you typed and where should we actually start looking. And so these following functions, I can't describe them perfectly, but a lot of them, what they do will start at the start of the string and parse through all the completions lists to see where we should be at. So this is the full UML diagram, and we'll continue on.
Okay, so the UML diagram is just describing how the program works, but how did us students figure out how this works? Because this code base is very complex, it's pretty difficult to figure out how things work. And so basically, the main thing that we use is our PureDefRed, the VS Code search function, to find the names of files / methods for the program. And so first thing that I would do is look up just the string text of the show completions option of the edit menu. And so if you actually just look up show completions, it's not super helpful. We have help.html, keys.xdb.csv. And so that's because there's actually a underscore under the H in the edit menu. And when you add this underscore, you go to mainmenu.py with the force open completions activator. And so if you just look up that in the search as well, then you'll be taken to editor.py for the editor window, because this is an option in the editor window. And you have two options here. We have try open completions and force open completions, which is what was mentioned earlier about forcing versus trying. And for try open completions is activated when you press the period, so that's what this keyword, these period is here for, as well as the slash and backslash for files. Whereas force open completions is just called when you actually click on the show open completions thing under the editor menu. And so if we go into the autocomplete.py file, we will see that there is the force open completions method here. as well as the try open completions event here as well. And there's actually a nice little comment that shows us what it actually is trying to do. And these methods end up going to open completions, which is where the actual like, completing thing happens. And what you'll notice is that there are actually these predefined variables up here. There's force, tab, try A, and try F, and these are just the various ways that the autocomplete is called. So force is either control space, or when you click on the show completions in the edit menu. Tab is when you press tab. Try A is when you press the dot, and it searches the attributes of the variable. And then F is for files, is when you press the slash. And each of these variables have 4 different components that basically change how the open completions method works. So if we go to open completions, you'll see that the initial thing here, right here, oh, nice. Here you go. These are the 4 parts of those predefined things in the parameter args. And when open completions is called, you'll see that it's called based on these args. So for example, in force open completions, it was called open completions and variable force, which basically just sets those variables to change how open completions functions.
All right, I was going to go through a quick walkthrough of the feature, but I'm not sure if I have enough time.
Maybe you could like focus on one part of it, maybe, or like show like just one piece of what you were going to do.
Yeah, it was going to take a while, so I was also going to do like an experimental code feature, so I might just do that.
Oh yeah, that sounds great. Do that.
And if you notice in this file, this line right here, it gets a basically like a pop-up wait time for when to show like the pop-up when you invoke the feature. And it pulls that from this file right here. And as you can see, it is set to 2000, assuming that's milliseconds, so just 2 seconds, which is just awfully long time to wait for the list to come up. But what I like to do is cut it down, make it 10 times faster, and you will see that this is much, much better. And so yeah, once I import something and then do like snapshot, it shows up significantly better. So yeah, I recommend you use this IDE for some reason to actually make this change. So yeah, I think that's it.
Okay, thanks.
Any questions?
Can you go back to the UML diagram? I was kind of confused, like, can you explain again, like, the editor, why are there 2 editors?
Oh yeah, so one of these is supposed to say PyShell. I forgot to edit that, so sorry about that. But yeah, there's 2, since this feature works both in the PyShell and the editor window, the virtual events are bound with both of those classes.
Okay, cool. Let's wrap it up there and give it more. All right, everyone. So in the last, we have like 35 minutes. We're gonna get through a few things. The first is sort of more of a miscellaneous topic that's just related to maybe some tasks that you might be encountered within your like internship or job. And the topic of this is called profiling. Let's wait for this loading. Okay, profiling. Okay. So let's just like think of this scenario where you're working on like some application or some like web app or mobile app, and your like manager is telling you that there's some parts of the code that are just running really, really slowly. Okay, and so let me actually just show you an example here. So if I just like run my my idlib to -m idlib, okay. And so it'll open the PyShell, and then this is like, say I'm the manager showing this to you right now. Now when I click on debugger, there's like a long pause, and then I get like that spinning ball that like tells you have to wait, and then it finally does it, okay? So let me just like show you that one more time. So we know that it should be way more instantaneous than this, but we know like something is going wrong, right? So before I actually maybe explain what profiling is, what's an idea or a couple ideas on how we would try to figure out what is not like working here? What might be the cause of it going so slow? Just like any thoughts what you might do? Any idea? Yeah.
Maybe look like some sort of like output log, see what's taking the most amount of time.
Oh yeah, okay, interesting. Maybe there are some log statements and timestamps so we can see maybe like in between if there's a long pause. That's an interesting idea, I didn't think of that. Any other ideas?
Saving state or changing mode.
Saving state or changing, sorry, what do you mean?
It's like saving file, like current state of each variable or like file, and like in changing like the current you originally in the shell and then turn on the debug mode or something like that.
Okay. I'm a little unsure what that means, but like one idea that maybe this is what you're referring to is like we could maybe like revert our changes to a different version of this file and try running it and seeing. Was that what you were saying, or is that different from what you were suggesting? Okay, never mind. I think I just didn't understand. We could maybe talk after. So like one idea also is like we can revert our changes to maybe something that was like several commits ago, and we can try running that version and see if it caused any change. We can maybe sort of isolate like which commit caused some of this like delay. So those are a couple of ways, maybe a little bulkier. We might have to like track down the person who made the commit, have a meeting with them, and figure out like why they made these changes. But one sort of like answer here is that we can do something called profiling, which I'm gonna sort of go over right now and then do a short demo. And then y'all are gonna do an activity where you'll actually also like run a profiler on your version of idlib. It'll be hopefully pretty fun. So okay, what is a profiler? This is like, I've linked the documentation, by the way, the lecture slides are on the website now if you want to access them. We have these like inbuilt libraries in the like Python executable that we built, the python.exe file. It can run this thing called cProfile, okay? And what this does is it lets you run your application and it'll tell you how long each specific method call is taking, and then it'll show you like in sort of like a log form output, like how long each specific method call is taking. And so this is a really helpful thing because we can actually like trace down, on a much more granular level, like what are the actual lines of code that are causing our application to take a long time. So for example, let me actually just run this. So let's actually, give me one second, we'll look through the documentation first. So this is like an example of like running cProfile just from like a script, okay? We can do cProfile.run, and then you can put like any Python command basically, and it'll tell you like how long each part of that Python command is taking. It'll tell you like how long this compile thing took to run, and it'll probably be like 0.0001 seconds or something like that. Actually, I think it shows an example over here. So you can see like these are like all the different calls that are happening just in this like short statement alone, okay? And then it tells us a few different like things, and maybe pay attention to this because you'll need to sort of interpret an output in a second as well. But it'll tell you like how many times each function was called, the total time that the function was running, and then like because the total number of calls and like total time running is just like an aggregate, like a cumulative value, you can also see the time per call, which might even be a little bit more helpful if a certain method is getting called a lot of times, and so the cumulative value might be kind of high, but we just want to see how long like a single call of that is taking. Okay. Oh, it looks like they have 2 per calls here. I didn't notice that. Interesting. Okay, so let me show you an example, right? So I just tried running my idlib, and it took a really long time for the debugger, right? So let me do, let's just show this one more time. We know it probably has something to do with the debugger, but we can't really deduce more from that from these like little changes, right? So we can look at the documentation here, and it actually tells us how to run it. And I've actually already put a version in this next slide here, which you'll be copying and running on your own. But let's run this for now. So I actually have like made a change to sidebar.py that's going to make this take a little bit of time. So let's actually just run this right now. Let's say good output. So when you run, so let's actually just break down what I did real quick. So I have this like python.exe. This is just saying we're going to use our Python executable to execute something. we have this -m. Remember, we also use this -m for just our idle lifting. This just means we're going to use Python to run a module. And then we're running the C profile module, okay? We're not running idle at first. We're telling it we're going to use the C profile library. We pass in this S flag. This is something you can find in the documentation, but it's just something for, S is for sorts in this case. We want to sort the output based on the cumulative time. And then we're going to run idle. And then this thing is just writing the log. It's just like, where do you want the file path of the log output? And so I'm running this, and this like just opened up. And so now I'm going to do like new file. And what I actually want to show is this. So like say I have show line numbers. I'm pressing like enter a few times, and then when I get from like 9 to 10, okay, it's going to take a little time. I actually just artificially added some code that's making this take a long time. And now I'm going to exit out of this. I'm not going to save the file. And now we should be able to, so like this, command has stopped running, so we're going to check this actual file, and it'll be in our idle directory. It's going to be a file called good output. So let's see where the G's, all right, good output. And then this is what the output looks like, right? So let's just take a second to think of what is going on here. So this tells us like how many function calls there were, and it's ordered by cumulative time. These are those different variables that we were going through, right? It's the number of calls, the total time, and then the time per call, okay? This is weird. I guess there were two different metrics that per call means, so you do have to like check this documentation. There must be a difference between the two. But anyway, I'll maybe figure this out on a separate time. Oh, primitive calls. Okay. So what we'll want to look at here is like how long each of these different things are taking, right? So one thing you'll notice, this is 66 seconds, okay? This is saying that this like built-in .exec took 66 seconds to run. Same thing with this run module, this like main method in PyShell.py. What's actually happening here is like from the moment we start idle-lib, it just starts a timer. And then there's some methods that are just like constantly running while idle-lib is open, okay? So let me actually just show like one more example. So we were seeing values that were like in the 60s just now. If I run this like one more time, and now I'm gonna do that again, but I'll try to go a little bit faster here. We'll do like show line numbers. And then when we get to 10, okay, it's gonna take a while to buffer here, but then I'm just gonna close it. And now let's see what the output value is in good output, okay? I wrote it to the same file. Let's just close this to make sure it's new. And then we have here, it's only in 15 seconds, okay? So that first time I like took it, I was like talking to y'all, I guess, for like almost a minute. So that's why it was in like the 60s. Here we have 15 seconds. But this is like still really hard for us to figure out what is going on, right? Like looking at this, we haven't used this before. We don't really know, like, is this like 0.05 a really long time? Is this why we're like dealing with so much buffer? Is this, I don't know, 0.16? Could this be the reason? And so something to sort of note here is that we like having a reference point to what I'm looking at here is really important, right? We would ideally want to have like a reference point of this output when we didn't deal with some like lag or some bug that's causing it to slow down, right? Because just looking at like this point alone is very difficult, okay? And so what I'll actually do, I'll just sort of show you what I had done because y'all are gonna do something very similar now. Is I had actually added this this is like a silly command called time.sleep. Okay, you import this like time library, and then time.sleep literally just says wait 3 seconds. Okay, it like just hangs for 3 seconds and it does nothing. And so the sort of like output here that you could sort of see is in this like sidebar.py, we have like the total time, the cumulative time was 3.003 seconds, and it says that it was called 10 times. But wait, does this make sense? Why was update sidebar text called 10 times there? Does anyone have an idea? Yeah.
You pressed it 10 times.
Yeah, I pressed enter 10 times, right? So it called the method 10 times, but the reason that this time.sleep only happened once is because it's only happening if there's a width difference, right? From when we were going over the sidebar class. So the like per call time is 0.3, but the cumulative time was 3 seconds. Of course, we don't know that this is weird because we haven't seen like a good example of like the how it should be running with like no sort of like added time. Okay. So what we're gonna do now actually is I'm gonna run this like same command without any sort of like weird thing happening. Let me actually also remove it from the debugger. I had done the same thing for the debugger. Okay, and so now we're gonna play this sort of, it's gonna be kind of like a game, okay? Where you're gonna pair up with somebody next to you. So let me actually just finish this real quick. Do a new file, press enter a few times. Let's exit this. Okay, so what I did is I just like ran the profiler with no time.sweep value, okay? So now when we look at this like good output, this is gonna be that reference point that I was like talking about. Like, I think that'll be so useful, okay? So now what we're gonna do, alright, we're gonna try this out. We didn't do this last year, but I thought it might be kind of fun, okay? So you're gonna get in pairs with like somebody next to you, alright, or if you can be like a group of 3 or something. And what you're gonna do is you're gonna like switch laptops temporarily, and your partner is just going to add this time.sweep command in a specific spot that I'm gonna tell you, okay? And you're gonna close your eyes while I'm showing it to like the opposite group. And then you're gonna get your laptop back, and you're gonna run this same thing, okay? You're gonna run this same thing with whatever output you want. You can call it good output or just like log or test or something like that. And you're gonna open that, and I'm gonna have like, you know, the reference version up here, and you're gonna have your version, and you're gonna try to figure out where that time.sweep command is, okay? Does that make sense to people? Are there any questions? Okay. Yeah, so you will just like hand the laptop, but please don't do anything bad on other people's laptops. So, alright, let's go ahead and do that switch. Y'all can be a group of 2 or 3, just give your laptop. And you have to switch it, okay? So make sure you find somebody to like give it to. Alright, so hopefully y'all have switched the laptops, okay? Hopefully y'all have switched the laptops. And now you're gonna decide like whether you're gonna be partner 1 or partner 2, okay? Like one of you is gonna be partner 1, one of you will be partner 2. If you're a group of 3, then you can just, you know, the third person can just choose one of them. What we're gonna do right now is if you're partner 2, you're gonna close your eyes, okay? If you're partner 1, keep your eyes open and be honest in this, okay? No cheating, no looking through your fingers, right? I'm gonna tell you where to add this time.sweep command, okay? So everybody, partner 2, close your eyes. Partner 1, keep your eyes open, okay? Partner 1, look at what I'm doing, okay? This is where I'm gonna add it, okay? So it's going to be in this file. You see this file up here, and it's going to be right here, okay? You see this line number in the file? Which one? You see the line number, you see the file, okay?
What file?
The file, oh, almost got me that time. Okay, so, alright, everyone got it? No. Everyone? Okay. Oh, sorry. Can't see it, so. Oh my gosh, I keep falling. Okay, so I'll give it a few more seconds here. Yeah, and then anyone still need time for copying this? Okay,
yeah, where's the file?
Couple more seconds. It's just these 2 lines: import time and time.sweep. And it's between these 2. Okay, all right, I'm gonna move on now. So wait, don't open your eyes yet. Okay, now you can open your eyes. Everyone can have their eyes open right now. But now, like person 1, you have to close your eyes, okay? And just switch. If you didn't have your eyes open before, now you have your eyes open, okay? Okay, so this is where I'm gonna do it, alright? Look at this file, go to this file. Okay? This is class, this file. And then you don't mind, right? And then this, okay? And then this. This is the line number that you have to add it. Just right under this line. Okay, a few more seconds here. Make sure just these two lines. We're in time.
We're watching the exact same time. Man, I've heard for the same Relax.
Oh yeah, y'all are also working on something that's not your own laptop. That might take extra time. Okay. Anyone need more time? Anyone need more time? Okay. Like a few more seconds. Few more seconds. Hold up. This is already good.
I'm gonna do the exact same.
So.
Oh my god.
Physical kind of says like what.
Yeah,
Oh, like yeah. Just don't look at this source.
Source control.
Yeah. Okay, that's smart. Let's do that. All right. Anyone need more time? Let's sort of get going here. Okay, so everybody can open their eyes now. And now what you're gonna do. Is run this actual command. You can get it from the slides. You run from the Python executable, run cprofile. Just copy paste this, but you have to replace the file name, okay? Importantly, you can't just keep it as the bracket file name. And then don't do .txt. I think if you force it to a txt file, it like really messes up the encoding. So something like this output. Something like this. Just no extension, okay? Just copy paste this,
Okay, I did it there.
and then run it, and then hopefully you notice something's taking a long time. All you should do to run it, by the way, is like run it and then just see the PyShell open, and then open up a new file, okay? And then you can close everything. Within those, yeah, you have to run the Python executable from the directory. Oh, no. Yeah. Okay, so maybe get this from the slides. I am going to show the good output, like the one without any issues, so that you can compare yours to the good output, okay? So y'all will run this, and you'll get some output file. You'll have to compare that output file to what I'm going to be showing on the screen. You're just going to try to find where it is. Okay, I'm going to have to do this. Yeah.
Is it normal to not have anything in the output file?
No, there should be something in the output file. So you have to run this. You have to run it from the like individual projects directory. Okay.
Yeah, that's what we did.
Sorry.
That's what we did.
Same here.
There's no output.
And we saved it. We saved I saved it.
I saved the first two. Yeah, maybe just wait for a little bit, like close the file and reopen it in VS Code, or open it from your Binder.
Don't quit with Control C. Just quit by clicking that.
Oh yeah, don't quit with Control C, because then it'll maybe just like undo the whole execution. Just like close out from the application.
Oh, we have to close the program.
What's not working?
There we go.
Global search. Well, yeah, you can do it with global search, but normally we wouldn't know that it's time.sleep. You know what I mean? So try to find the function like using this.
Wait, so the thing is, I think you guys haven't compiled PyCode.
This is the output. Okay.
It's like
Or is it? No,
So you should get the output, and then when you open the output in VS Code, it'll look something like this, and you'll probably need to look for something that's in yours that isn't actually here. Like you should be comparing yours to, yeah. Sorry, where's It's not, like, it's not naturally. To actually get some output, you have to like, yeah, you have to close idle lib, okay? So like when you run it and you do like file, new file, and then just close it through like exiting, okay? Don't do Control C or anything else.
Wait, should the output still be the same directory?
The output will be in lib idle. I mean, you can put the output anywhere, but just for ease of opening it in VS Code.
I open it. I look at over these all these.
I know, but
it says Mars
the thing is, global search before gave me like 3 versions.
Yeah, there's already time.sleep in the.
No, but there's already time.sleep 3 times over.
Yeah.
When I did it again, though, I was able to find only one.
You were able to find the wrong one?
No, only one instance of time.
Maybe because only one was hit, right? In the running secret one. It's just based on what's hit. Okay, was anybody able to find where it is? Alright, we're gonna actually like end the activity now. You can keep doing this on your own maybe and like work through it with your friend. Alright, let's get the 2 answers. Yeah, what did you find?
In editor.py set status bar.
Yeah, nice. Okay, that's cool. And how were you able to see like a difference between
Yeah.
Okay, what showed up here? Was it just editor.py and then like where was it?
I accidentally closed my output. Hang on.
Okay, that's fine. Maybe like what line number was it on? Just like how far down?
Oh, I just noticed that PyShell.py. Let's see here. What line?
Okay, that's okay if you're not.
No, it's just like any mention of the PyShell.py or editor.py had 3 more seconds than.
Oh, okay. Oh, I see. Okay.
So I thought to look at one of those 2 files, but this might have gone against what we're supposed to do. But I looked at the files and I just
searched.
I didn't even search. I just looked at the Explorer and it just said modified, and I'm like, what does this mean?
Okay. Darn, I was hoping to avoid that. All right, did anyone find the other one? If you weren't like whichever like partner number this guy was. Yeah.
Maybe it's in the begin method.
In the what method?
The begin method.
Yeah. What file?
Or PyShell.py.
Okay. Yeah. Begin PyShell.py. Yeah, and it was down here, right, between focus force and show prompt. So like the way this would actually look, I just thought this one was a bit interesting. If we run this like command again, it takes a while for the actual like prompt to pop up. And so like it is somewhere in the like PyShell file, but you can actually see like half of it being done, and then it doesn't show the prompt until after the time of the command. Okay, so hopefully you all just like got to see and like try out a bit what the what profiling is. In these last 12 minutes here, we're actually going to give you all time to do the set evaluations, okay? So they actually recommend this for like increasing the response rate, to just like set aside time in class. And I think since this class is sort of in its early stages, we're hoping to grow it to a lot more students. We really want to like hear some like honest feedback about how this class has gone. And this is actually kind of like the end of the main lecture. Like the next lecture is going to be the skill demo, and then we have the final presentation. So this is close to like the end of most of our like interactions, I guess, or like me teaching y'all. So please like sort of be on. This is all anonymous. I'm not gonna see like who wrote it, so you can be as negative as you want as well, or as positive as you want, hopefully. But go to this like website set.ucsd.edu, and then you can go to evaluate your course. Okay. And then you should have quite a few options if you're in multiple courses. I think it'll give you multiple ones. Just do the one for CSE 190 right now. And try to, write out your thoughts and sort of, fill it out thoughtfully until 4:50. And I'll end with a couple announcements, but yeah, please take some time for it. Yeah.
Oh, that's just the first. Just first so first.
Oh, okay.
I mean, I was not able to I was not able to get the output.
I got one with that how they found the geotan like
Oh, is that what they did? Are you serious? I didn't know.
All I heard was that the person was running benchmarks and noticed that it was like half a millisecond.
Oh, yeah. Oh, that's crazy because I talked about that like.
Yeah, you were talking about week 2, and when you showed profiling, I immediately thought like,
That's awesome. Okay.
I'm just asking.
No, you're right. I think you're right. That's exactly how nice. And then also, once you finish the set evaluations, just for today's participation form, it's a really quick question about just whether or not you recommend this class to a classmate and why or why not. They took that off of the CAPES evaluations that was happening a couple years ago, but I think this is a good question to hear whether or not you recommend it and why or why not. This one does have your name on it though, so because we're going to collect it for attendance data, so just keep that in mind.
That's it, yeah.
No, I mean, wait, no, you should get like an you put 3 words, one component.
Take your time for this. We've still got about 8 minutes. If you finish early, you can fill out the IA evaluations for the tutors. Might not have interaction with all the tutors, but please do give your feedback for the tutors that you did interact with, right? Yeah, so please try to fill all of these out. Maybe write out a few actual sentences for the last question.
Well, we can't read the book. Or at least you can shut down both. Or you can shut down one. I just took it as both. Actually, the other what? What's the other one? The drop down? Actually, it's a lot less simple than I thought.
I think you should invite the students that are in this class that are getting into
it was actually great.
And basically we should talk about how this is going.
Yeah.
Because I'm already using
yeah, we're working pretty much last time was like, okay, this was a lot, and there's a lot more.
Now that I know and also I think I found something that's doing, but like because I have to review the report and then
or not,
like they're
going to be doing it
way faster. I told you, I gave you.
Yeah. It doesn't mean anything like to review that.
I wasn't under the impression that we'd be working on it.
I guess. I go there
I can look at it.
Right now? I wasn't seated for one of them and then I talked to another, what do you
It's like, at some point, it's just way too.
Oh, good. We're gonna miss you.
Because I honestly,
I thought right now. Oh, go ahead.
We just say finally, we just do.
No, it's just like careless. Like we do have to go. Like today, you're stupid. Like we didn't do that.
So you're still, are you active?
You're like an app.
Yeah, you can just talk to the
it's like a lecture.
Yeah, it's part of exploration. I think I mentioned that like a couple of times. Okay, everyone. So everyone just listen up for these last couple minutes. I feel like there's a lot of conversation, which is awesome, but I just want to make sure that like a couple things are clear. Sorry, everyone can like listen up here. So for those of you, if you haven't completed the set evaluations, like I just want to reemphasize, this is like super important, or like super helpful, I guess, for like me, Gerald, and like the CS sort of like department to know where this class should go in the curriculum and like how it's sort of been so far. So please, if you didn't find the time in this class, please do like outside of class fill these out. Again, the participation form is for attendance today, but then importantly, the skill demo, the final skill demo on Thursday. Make sure you bring your laptop and please have it sort of fully charged because you'll be doing like a Zoom screen share. And I'll just like quickly show what that's actually like. Like you'll have Zoom installed. We'll just do like new meeting, okay? So then you'll like start sharing your Google Chrome, okay? And then you're just gonna do record to the cloud, okay? So it's actually not gonna record or save to your laptop or anything. You'll just record to the cloud and then you'll do the skill demo, okay? If there is some like sensitive information that does pop up or something, you can talk to us and let us know and we'll scrub that or like remove that as best we can. Or if you just don't feel comfortable, you can make a post on EdSTEM. But you'll just like record this to the cloud, and then later after it finishes the meeting, you'll just be able to send us a link to that, and we'll be able to just download it on our own. You won't have to like download it or like use any like storage space on your own laptop for this, okay? But please do just have Zoom installed and have your laptop fully charged, okay? And please fill out the sets again. Oh yeah, question?
Where do you get information about the
The exploration activity is like linked over here, and I think it's also on the schedule. Let me slide. So it's on the schedule here. Exploration activity 3 is due Thursday. Yeah, just make a couple plots on Matplotlib, and that's all you need to do.